Hi everyone, welcome back to another video for Algebra 2. Mr. Beceda here. And our first video today, in fact our two videos, will both be about a new topic called function composition. Now, function composition sounds really complicated, but it starts with something pretty easy, and that's what we did last week with evaluating functions. So I'm going to start just to kind of get ourselves into this with these two questions. If f of x equals 3x plus 4, find the following: f of c and f of a plus 2. Now, when we try to find those, nothing too complicated here. These are just substitutions. So in the first one, I'm going to take that variable c, and I'll go into my equation 3x plus 4 and replace the x with the c. Now, when I'm just substituting a variable in, that's all I need to do. My final answer here is 3c plus 4. In the second one, where I have f of a plus 2, then that means the entire a plus 2 is going to go into the function for x. And in this case, I will go ahead and use parentheses. As a reminder that I need to distribute that 3 into both terms. I'll do that and finish by combining like terms. My final answer on the second one here is 3a plus 10. Now, like I said, we saw this last week when we first started working with functions, and what we do today is going to be pretty similar to this, just with an additional step. And this is called function composition. These two videos, the first one will focus on function composition with numerical values, and the second one will work on algebraic values that I'm substituting in. Remember, we talked about that distinction last week, where if you substitute a number in, your answer should be a number. And if you substitute a variable in, your answer usually includes a variable. So let's start here. We're going to use the two functions f of x equals x plus 3 and g of x equals 5x plus 11. Now, the thing they're asking us for here looks like it would be very difficult to say. And the way we read that is f of g of 2. F of g of 2. So basically, it's kind of like a problem inside of another problem. And the key for performing function composition, which is what this is called, is starting on the inside. So for this problem, the innermost thing that I've got is g of 2. And now g of 2 we've already learned how to do. That just means I'm going to substitute 2 into the function g. The function g is 5x plus 11, so I'll go in with a 2 instead of that x. And that gives me a value of 21. Now, that's not our final answer because this is function composition. Function composition always has more than one step. The second step is I'll take that answer of 21 that I have, and now I'm going to put that into the outer function. We've already done g of 2, and now we're going to put that into the outer function here, which is f. So now I will find f of 21. And that means going into the function f above, which was x plus 3, replace the x with 21. And that gives me my final answer of 24 for f of g of 2. Now, this is one of those things, if you're watching this video and you're saying, that's crazy, this is totally nuts. People normally say that when they see the first example or two, but give it time, give it a few more examples, and this is actually one of the easier things you'll do long term once you get used to it. I'm going to erase a little bit over here and we'll work through the second one. I have f. They want me to find g of f of negative 4. Step 1, again, work from the inside. The inside here is f of negative 4. That means I need to go to the function f and substitute negative 4 for the x. And this time that gives me negative 1. That's my first, kind of like my intermediate answer. Now, look at the outer function. I've done f of negative 4. The outer function would be g. So I'll do g of the negative 1 that I got in the previous step. G of negative 1 going to the g function, which is 5x plus 11. works out to give me a final answer for this problem of 6. Okay? So once again, substitute the value into the innermost function, take the answer from that, and substitute it into the outermost function. And that's how function composition works. We'll take a look at a few more examples here before we wrap up this first video. I've got f of x equals x squared and g of x equals 5x minus 2. Now, if you would like to pause it here for a second, if you think you've got what's going on and you want to try these, go ahead. And if not, we'll go ahead and look at them together now. So number 1 wants me to find f of g of 2. The innermost thing there would be g of 2. That means go to g of x, which is 5x minus 2, and replace the x with a 2. I work that through, that gives me 10 minus 2, which is 8. Of course, I'm not done yet. I need to take that value and go into the outer function, which is now f. So I will find f of 8. And that function was just x squared. That gives me 64, and that is my final answer for the first one. For our second problem down here, we have g of f of negative 2. Innermost function here is f of negative 2. So I'll start with that. One thing we've talked about before is making sure that when we put numbers into equations, we do use parentheses. It's especially important here with f of x, because if I forget the parentheses on that negative 2 squared, I'll get a wrong answer. But negative 2 squared is positive 4. I will take that, and I will substitute that into the outer function, which is g. And my final answer for the second one is 18. And that is how function composition works. It really is just evaluating functions at certain values, but there are 2 steps instead of 1. One final thing I want to talk about with function composition is that the order that I do this problem in does make a difference. So if I were to ask if f of g of x and g of f of x are different, the answer is usually yes, they are. Not always, but usually. So if you'd like to do a quick practice again, you've seen quite a few examples. I'd like you to try doing f of g of 7 and g of f of 7. You can pause the video now if you want to work it through before seeing the answers. Now, if I were to actually do this then, on the first one, I would start with g of 7. Whereas on the second one, I would start with f of 7. Now, we're going to see how this actually turns out differently. If I go in with a 7 to g of x, I get a first answer of 46. I will then, of course, take that 46 and put that into the outer function, which is f. And that function was just x plus 2, 46 plus 2. I get a final answer of 48. However, if I try to do g of f of 7, this looks a little different. The 7 goes into f of x first here, which gives me 9. Then I'll bring that 9 into the outer function, which is now g. And I get 56. This is just a little additional evidence that, in fact, f of g of x and g of f of x are oftentimes 2 different values. In this video, we covered function composition with numerical values only. In the next video, we will cover function composition with algebraic inputs instead of just numbers. So be sure to watch that one as well. Thanks for watching.